We're going to start talking about quantum. It's different than how you tackle quantum in chemistry. We're going to talk more broader about what quantum is, and we're going to kind of also include a little bit of focus on the historical and why we have quantum. Truth be told, we've already done quantum, and we've already done it this quadmester. Quantum is just a translated word that basically means a quantity that's delivered in bundles or multiples of a base value. When we looked at the Millikan lab and the charge on an electron, that was our first of a few times when we got to quantum. Electric charge is quantized. Every charge must be a multiple of that base charge of the charge on a single electron. When we talk about quantum physics, usually we're not referring to the charge. It's another quantity that we'll get to as we work through this. Um, Basically, there was a lot of weird things going on in the late 1800s. There was all this kind of new physics that was being developed, and new math, and new ideas, and new experiments based on literally math being more sophisticated as time progressed, and experimental procedures being more sophisticated as time progressed. So these older physics models that in hindsight were kind of simple and based off really simple experiments, they weren't agreeing with the observations of the new theory. So kind of a famous quote by this author, Thomas Henry Huxley, author, philosopher kind of guy. He said, "The great tragedy of science is the slaying of a beautiful hypothesis by an ugly fact." Basically, when we're working in science, it's the experiment or the real world that drives it. If you've got an experiment that doesn't, if you've got an experiment can't prove a model is correct, it just sort of validates it and confirms it. So we can't prove a model correct, but if a model doesn't match an experiment can prove the model wrong. So we can verify things with experiments. We can never truly prove them, but we can definitely disprove a model. If an experiment doesn't agree with a model, then we have to replace that model. And that's kind of what Huxley was going with. An ugly fact, an ugly experiment, slaying a beautiful hypothesis. This first one's just going to be a shorty. What we're going to start off is I'm going to show you sort of the motivation of why quantum was developed. So I think there's two instances we'll talk through. What I would like you to do is pause, we'll stop this video and watch this video clip, and we'll carry on and talk about it.